All right, hello everybody. Today we're going to be looking at section 1.3 using the midpoint and distance formulas, and that's going to be on page 20. Again, if you want to follow along in your book, then you're more than welcome to do that. That's why I have the page number in the corner of the slides. But if you just want to follow along with me on the notes, then that is totally fine as well. Just a little bit of review before we dive into today. So far, we have looked at a few things in this chapter. We have reviewed some terms, and those have been things like the definition of a line, a ray, a line segment, a point even, coordinate planes, all that kind of stuff. And we have also looked at the segment addition postulate. And pretty much all that said was that if we have a segment and it's split up, and let's say we know that this whole segment is 10 and this little part of it is just 3, the segment addition postulate said that we are allowed to take the whole, we're allowed to subtract that part, and then we can figure out what this other part is. So that's the very simple version of it. There are a couple more problems that were a little bit more complex, but that is the basic definition of the segment addition postulate, or one way that we used it. So that's what we've looked at so far. Now we're going to get into some more stuff with midpoint, just like the title of this section says, and the distance formula. Those are going to be the two things that we're going to look at. And we're going to use all of those terms and a lot of those ideas that we've talked about in the first two lessons to kind of frame the conversation of what we're looking at today. So our learning targets. Students will be able to describe what a segment bisector is and draw a situation explaining a segment bisector. The second one, students will be able to use the midpoint formula, one of our keywords, to find, well, our second keyword, to find the midpoint of a segment. And students will be able to use the distance formula to calculate the lengths of figures. So there's something I want to point out about all of these three keywords. The first one, segment bisector. Well, let's just break that word apart. We have a segment. To bisect something means that we split it or cut it or something like that, to bisect it. So that could give us a hint of what we're talking about there. The midpoint formula. Well, we know that mid means middle. So the midpoint, again, if we're talking about a segment or a line or something like that, the midpoint we can assume is going to be the middle, and point, well, we know what a point is. Formula, we'll get to that part. Last one, distance formula. If we have 2 points, and we know that in general the distance of something is how far it is from here to here, we can probably assume that the distance formula is going to give us some type of formula for how we can figure out what it is from here to here. Now, those are very basic definitions of each of those words, but let's keep those in mind as we go through each of these, because I think it's going to help us to understand. Segment bisector is a really weird word, but if we break it down, then we can pretty easily see what it means. So let's dive into these terms a little bit more. The first one, midpoint. The midpoint of a segment is the point that divides the segment into two congruent sides. So over here we have a segment A, B. We would label that just like this, segment AB. The midpoint, you can see point M divides into two equal sides, and we know that for sure. I don't know how easy it is to see here, but we know that it divides it into two equal sides for sure because it has one tick mark on each half. So that tick mark means that this side here is the same as this side here. So the midpoint, point M, is the midpoint that divides that segment. So a pretty straightforward definition there. The second one, a segment bisector. A segment bisector is a point, ray, line segment, or plane that intersects the segment as its midpoint. So we have the same drawing. We have point A, point B, and point M right in the middle, but this time, instead of just the point being what divides that segment in half, we have a line that divides that segment in half. So not a huge change there. When we had the definition of a midpoint, we knew for sure it was talking about a point. When we look at a segment bisector, then we could be talking about a line. Well, we could be talking about a point. We could be talking about a line. We could be talking about a line segment. It also says that we could be talking about a ray. Well, the ray probably wouldn't look like that. The ray would probably have an endpoint here and go like that. We could be talking about a ray. We could be talking about a plane. I'm not going to draw that. But all those things would be a segment bisector. So if we think about it, the midpoint is inside a segment bisector, is under the kind of umbrella of a segment bisector. So we're just going to jump into a couple of examples here, and that's going to be all that not all that we look at today. Those two terms are the only two terms that we look at today, and we have a couple of examples here. In the skateboard design, which you can see I beautifully cropped out of our textbook right over here on the side. In the skateboard design, VW, so VW right here, bisects XY. Bisects this whole thing of XY at the point of T. So the point where it bisects, the point where it crosses XY is point T. We can see that pretty plainly through our example. XT, so running out of colors. XT, so from here to here, is 39.9 centimeters. Find XY. Whoops. We want to find X, so here to here, XY is what we need to find. Now, it tells us that XT, or where to go? It tells us that VW, so it tells us VW bisects XY, but it doesn't tell us for sure that this is the midpoint. So we can't right away, just from reading that, we can't just assume that XT is half and that we can just double 39.9 to get the answer. What we need to look at, and maybe this is hard to notice if you're not looking at your textbook, but what they want us to notice is that there's a little tick mark here and a little tick mark here. So like we talked about earlier, that means that this line is the same length as this line, and now we can assume that that 39.9 is half of X, Y. That, in other words, we can assume that T is actually the midpoint because of these little tick marks. That tells us that those two segments are the same. So my point that I was making earlier is that we cannot just look at these, and since it bisects does not mean that it bisects right in the middle of the segment. So we couldn't tell that it was the middle just by knowing that it bisected X, Y. We could tell that it was the middle because of these tick marks. We could tell it was the midpoint because of that. So to find our answer, 39.9 is the first half that we have. 39.9 is the second half. If we add them together, then we will get 79.8. So we can find the whole thing equals 79.8. This is very similar to how we use the segment addition postulate, except this time we have more lines, like we have the line VW bisecting xy instead of just saying, hey, this is the midpoint, go find what the other half is. It's a little bit different. Here's a more realistic example to what we would see on a test or a quiz. Point M is the midpoint of VW. So point M here is the midpoint. This time it tells us it's the middle, splits it right in half. We also have our tick marks to show that. Find the length of VW. So it wants us to find the length, of VM. It wants us to find the length of VM, so just that section of it. The way that we do that is we look at it and we know that this half from here to here is represented by this equation that I circled. We know that this half is represented by this equation. We also know, since they told us it was the midpoint, that this half has to equal this half. So that means this equation has to be end up equaling the same as the other equation when we plug x in. So we're just going to set these two equations equal to each other and solve for x. So we find out that x equals 4. A very easy distracting answer on a test would be to have 4 on there if it's a multiple choice question, but the directions say find the length of VM. So we need to, the length of VM is 4x minus 1. We know that x equals 4, so we need to plug it in. 16, 4 times 4 is 16, minus 1 gives us 15. So we can see that the length of VM equals 16. Line VM equals 15. My fault. And you'll have questions like this on your homework. Now we need to look at two formulas before we can finish up. We have the midpoint formula, and later we'll look at the distance formula. So the midpoint formula is one that you might want to write down to refer to it later. And that formula is x1 plus x2 there we go. X1 plus x2 over 2, comma, y1 plus y2 over 2, or divided by 2. Now this formula really should be not a huge surprise, right? X1 and plus x2, those will be our two endpoints, and we want to divide them by 2. So just like if we had two numbers and we wanted to find what the average was or what the middle was, we would add those two numbers together and divide by 2. Same thing goes for our y. Now remember, the midpoint is an actual point on our graph. So if we have this graph over here, the midpoint is going to be a physical point somewhere here in the middle, probably somewhere where I scribbled, somewhere in that area. So it shouldn't be a surprise that we have an x value, comma, a y value, that it's a coordinate point. Now, when we find the midpoint, we want to take the two end points, those coordinates. So we have 4, 2, and 1, -3. We want to take the two end coordinates, and I like to label them. So we know we have an x and a y, we know we have an x and a y, and just because it makes sense, let's call this first one x1, y1, 2, y2. If you did it in a separate order, if you said that 1, -3 was x1 and y1, and the other one, 4, 2, was x2, y2, then that's okay. It does not matter which order you put these in. It does matter that both x and y are 1 and both x and y are 2, that you keep the pairs together. So let's take our coordinates and plug them into our formula. x1 we said was 4, x2 is 1 divided by 2, y1, which is 2, plus we have a -3 for our y2, and And again, this is divided by 2. 4 plus 1 gives us 5 over 2. We can just leave that right in fraction form. 2 plus negative 3 would give us negative 1 over 2. So what that tells us is that our midpoint, or the midpoint of this line segment of SR, is 5 over 2. So that's about 2.5. So 1, 2.5. Negative 1/2. So if 1 is here, negative 1/2 is about here. So this point right there would be our midpoint. Really, this setup that I had here of writing the formula first, then writing your 2 points and just making sure here that you keep which one is first, which one is second, keeping that straight. And then we just plug our numbers in, plug our points in, and do a little bit of simplifying, and we can find our answer. So not a too lengthy process there. When you do your homework, this is what I would expect to see, is that you, at the very least, what I should see is this right here, of you plugging those numbers into the formula, and then your answer like this. I should not just see an answer there. I want to see the work. Now the distance formula. Here we have another formula, the distance formula. So this time we have the line segment RS. RS. So we say the distance of RS, and here's the formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. Now that looks like another kind of crazy, uncomfortable formula because there's a square root in there. There's squares, or to the second power, inside of the square roots. But if we can break it down a little bit, it's not too bad. So again, we're going to take the points that we want to find the distance to and from. So the question for this one would be something like, what is the distance from point R to point S? Or what is the distance of line segment RS, or something like that. So we would take those 2 points. So point R is 2, 3. Point S is 4, 1. Oh, negative 1. And again, I like to label. We have x1, x1, y1, x2, y2, just so that when I plug them into my formula, I keep them all straight. Now we want to plug them in. So RS equals the square root of x2 is first. So 4 minus x1, which we said was 2, squared, plus y2, which is negative 1, minus y1, which is 3, and squared. Now we just can simplify. So 4 minus 2 is 2 squared would give us 4. Negative 1 minus 3 is negative 4. Negative 4 squared is 16. So we have the square root of 20, which is about, oops, that's not what I wanted to do, not congruent. It is about, these squiggly lines mean kind of an estimate, or close to 4.47. I think your book rounds that up to 4.5. So again, what I am expecting to see on homework is that you, at the very least, set up your equation, or set up your formula and fill in those points in your formula, and then some process of you solving. Okay, and what this answer tells us is that the distance from R to S is 4.47, and we don't have feet, meters, whatever, so just 4.47 units is the distance between those two things. one last note about this is that we should be pretty familiar with this x1, y1, x2, y2, and that kind of notation and that form in these formulas, because way back to algebra 1b, I think it was algebra 1b, when you learned slope, you did similar things with y2 minus y1 over the top of x2 minus x1. So it's a familiar notation to us, so this shouldn't be too tricky. Now let's take a look one more time at our learning targets. Students will be able to describe what a segment bisector is. Well, a segment bisector is anything that bisects a segment. So we have a line, a point, could be a ray, could be a line segment, could be a plane, which I can't really draw. And draw a situation explaining a segment bisector. So if you can draw something close to what I did there, you nailed that learning target. Students will be able to use the midpoint formula to find the midpoint of a segment. So the midpoint formula, again, you'll want to have it written down, but that is this formula right here, and you can find that in your textbook on page 22 if you wanted more information or a clear look at it. And you will have practice using the midpoint formula in the practice for this lesson. And then the last learning target was that you could use the distance formula, and that is this formula right here. So instead of saying RS equals, you would just say distance equals the square root, blah, 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 through there. Oops. Okay, so that is what we're looking at in lesson 1.3. Just a little preview of what we have coming ahead. Lesson 1.1, 1.2, and 1.3 will be something that we quiz on early next week. So if you're not understanding anything from what we've talked about so far, then it's going to be really important to email me, let me know. We can talk about some things and clear up some things, but otherwise,